Good evening, students. This is Tuhin sir, and we are going to talk about friction. This is my first video on friction. Supposing a car is moving at a speed v towards the right. Now, if the driver were to put the engine off, what do you think will happen? The car will move a certain distance and it's going to stop. So why is that? Because there is a friction force denoted as small f acting backwards. Now supposing and today we are going to talk of friction on bodies placed on horizontal surfaces, not on inclined planes, etc., etc. Now suppose this is a body of mass m and you are being asked to pull it with a force. Let me draw two cases. In the first case, the surface is the floor of the house. In the second case, the surface is an ice skating rink. Where do you think you will find it easier to pull the body? In the ice skating rink. Because an ice skating rink, the surface is smoother compared to the floor. So, more the friction, rougher the surface. Before moving forward, we would like to, or rather you should be particularly aware of what is the job of friction. The job of friction is to oppose relative motion between bodies. As long as possible. So the job of friction is to oppose relative motion between bodies as long as possible. Now suppose, as was told just few minutes back, there is one block of mass m. What is the force with which the earth attached the body, which is the weight? It is mg. If it's a horizontal surface, and we are talking only about horizontal surfaces, what is the normal force exerted by the surface on the body? Normal force is equal to mg. Supposing you are being asked to pull a book which is 3 kilogram. So what will be the mg? 3 into 10, which is 30 Newton. I am taking g is equal to 10. So what will be the normal force? Normal force also will be equal to 30 Newton by the surface on the body. And you are being asked to pull it. Another hypothetical case, I have a 3 kg block, on top of which I put another 2 kg block, and I am being asked to pull the block on the bottom. Which one do you think will be easier to pull? The first one, because in the second case the composite blocks 2 plus 5 will be attracted by the earth with a force of 2 plus 3, which is 5 into 10, 50 Newton, and the normal force exerted by the surface on the composite block will be 50 Newton up. Now, what is friction? As we discussed in the while discussing the example of a block being pulled when kept in a floor and block being pulled when kept in an ice skating rink, there is something which defines the roughness between the two bodies in contact, and that something is called the coefficient of friction. Which could take values of 0.1, 0.2, maybe even 1. And that coefficient is defined as mu. And by definition, friction force, which is denoted as small f, is mu into n. And if the body is in a horizontal surface, n is equal to mg. So friction force is equal to mu mg. If the body is at rest, the mu is called mu s, which is the coefficient of static friction. If the body starts moving, then it becomes kinetic. So it is mu k, which is the coefficient of kinetic friction. Okay, let's move forward. And friction limiting or also the maximum possible friction is denoted as mu Sn. So that's the maximum possible friction possible. So now let us understand with the help of an example, what is this mu? So supposing this is a 5 kg block, so mg is equal to 50 Newton. Normal force exerted by the floor on the block is also 50 Newton. You are being asked to pull it with an external force, and students, by external force F, external force is always denoted as capital F. Now supposing you are being asked to pull it with an external force of 20 Newton, and the coefficient of friction between the block and the surface, and this is the surface, is equal to, let us say, 0.5. So what is the friction limiting in this case? By definition, it is 0.5 into n, which is 0.5 into 50, which is 25 Newton. So a maximum of 25 Newton friction force can act towards the left. But will it? No. Because, as was discussed, the job of friction is to oppose relative motion between two bodies in contact. And if 25 Newton were to act towards the left, the body is moved towards the left relative to the surface. And friction is not going to violate its job as long as possible. So what will it do? It will apply a force of 20 Newton only towards the left, so that the block remains at rest. So what happens to the mu? What happens to the mu is, to apply 20 Newton towards the left, mu is equal to 0.4 is enough. So 0.4 into 50 is equal to 20 Newton. So it will not apply the entire 0.5 which it could have applied, but instead apply only 0.4 so as to keep the two bodies, so as to not allow the two bodies to have relative motion. Now suppose you increase the external force to 24 Newton. So friction force will again be 24 Newton towards the left, which means 24 is equal to mu into 50. So mu is equal to 24 by 50, which is 48 by 100, which is 0.48. Mu of 0.48 is being applied in this particular case. Now if this external force were to increase to 25 Newton, the entire 0.5 has to be used so that the two bodies remain at rest, so that the body remains at rest relative to the surface. So the entire 0.5 is being used up in this case. So the friction has been doing its job until now, like I've said, as long as possible. Now what happens if the external force were to be 25.1? That exceeds the maximum frictional force possible, 25, by 0.1 Newton. So the body starts, so that there is a net force towards the right, and according to the second law, net force on a body is equal to mass of that body into acceleration of that body, and net force towards the right is 0.1 Newton. So the body will start accelerating with 0.1 by 5 kilos mass, which is 1 by 50 meter per second square. So now friction has given up. It did its job until the external force was 25. Beyond 25, it's not possible for friction to keep the two bodies not in relative motion. So now the relative motion starts and the body starts accelerating towards the right. So what happens? What happens is that now the body, since the body is in motion, now the friction force that's going to act, friction force kinetic, because the body is in motion, is mu k into n. And remember, students, mu k is always less than mu s. Physics is nothing but observation of nature. If you have experienced a situation, probably you are traveling in a car and suddenly a tire gets punctured. Now you got to pull the car to the gas station. car is probably maybe 200 kilograms. You will probably need 4 men to pull the car to the gas station. But once the car starts moving, maybe just 2 men can do the job of pulling the car to the gas station, which means friction kinetic is always less than the static friction. I hope you liked the video, and please don't forget to subscribe or to press the like button. Thank you very much.